In 8.2, one of the types of series we want to look at is the telescoping series. This is the weird one where you get this collapsing and there's a lot of cancellation. Generally, you'll be told that it's telescoping if you need to, but if none of our other techniques work, then this is always something you can try. It always works when you see something you can write as a partial fraction. So, we would first say that this is 2 over n times n squared minus 1, which is 2 over n times n plus 1 times n minus 1. And now it's set up to do a partial fraction decomposition. I hope you'll let me skip that, because you can look back in chapter 5, section 7 to see what we did there. But this is going to give us 1 over n minus 1 minus 2 over n plus 1 over n plus 1. So the denominators are 3 increasing numbers, consecutive integers, and the tops are a 1 and a minus 2 and a 1. Makes it a pretty easy pattern. When we're doing telescoping series, we're looking at the definition of a series. So we want to find the general term s sub n, the partial sum, so that we can look at s as the limit of the partial sums as n goes to infinity. Well, we need to have this formula in order to find that limit. So to find that formula, we start writing out partial sums like you did in class on whatever day that was, Wednesday. So we could write out a few, but if you notice, we always want to just get the general term. So here's how I do it personally. I like to see what happens when I just start adding terms. If you were just doing it the old way, you might say S1 or S2 because it's either the first partial sum or because it starts with an n equals 2, so there's a little ambiguity. But since we're looking at the limit, it doesn't really matter. So S2, I would say, is the first term. 1 over 1 minus 2 over 2 plus 1 over 3. That's just taking our formula right here and plugging in an n equals 2. The denominators are 1, 2, 3, and that pattern will hold. You could simplify the 1 over 1 and the 2 over 2, but that's going to hide any patterns we see. So I recommend not doing that. S3 is going to be the first term, 1 over 1 minus 2 over 2 plus 1 over 3, plus the next term, which is going to be the next denominators, 2 minus 2 over 3 plus 1 over 4. So the denominator is 1, 2, 3, and then 2, 3, 4 makes this one a pretty easy one to work with. And this is why you don't simplify the numerators, or the fractions. You want to be able to see how many thirds we have, and how many fourths we have, and how many halves we have, and hope that it all works out pretty nicely. So this is the old way. If you were to keep doing this, you would try to find a pattern for Sn. But to get Sn, we're just adding up a lot of terms and seeing what canceled. So if you know that it's a telescoping series, I generally just start writing out the terms. So Sn equals the first term, 1 over 1 minus 2 over 2 plus 1 over 3, and that's when n equaled 2 because it was the first one. Plus the next one, 1 over 2 minus 2 over 3 plus 1 over 4. So that was when n equaled 3. So the n always matches the middle term. Plus, when n equals 4, we get 1 over 3 minus 2 over 4 plus 1 over 5. Keep going. Plus 1 over 4 minus 2 over 5 plus 1 over 6. This was when n equaled 4. This was when n equaled 5. We'll do 2 more and then we'll stop. When n is 6, you've got 1 over 5 minus 2 over 6 plus 1 over 7. That was when n equals 6. And when n equals 7, you have plus 1 over 6 minus 2 over 7 plus 1 over 8. And it really keeps going. But if I want to know what Sn is for any n, I just stop at the time that I used that n. So now we've written out a first few terms. We want to see if anything cancels. This is why we left them in the general terms, and it'll never really cancel the first terms because they don't have other terms to cancel with. So we look kind of in the middle, and I see that I've got a plus 1/3, a plus 1/3, which cancels with a minus 2/3. So those all went away. Then I'm going to check my fourths. I've got a plus 1/4, minus 2/4, and plus 1/4. And that pattern's just going to keep happening. I'm going to have a plus 1/5 here, a minus 2/5, and a plus 1/5. Then I have a plus 1/6, a minus 2/6, and a plus 1/6. Now if you look back at the start, there might be canceling unofficially, like there's a plus 1/2 and a minus 2/2, but that doesn't really have anything to do with the pattern that's going on because there's not enough to cancel it out fully. So when you do telescoping, there will always be some terms that stick around at the start, and you've got to write it out far enough that you can see, and some terms that stick around at the end for your last n. So our job when we're trying to find Sn is find this pattern. So since this was n equals 7, I want to try to write Sn using an n. So in this case, Sn was, let's do with 7 first. S7 was 1 over 1 minus 2 over 2 plus 1 over 2. And then at the end, we still have a plus 1 over 7 minus 2 over 7 plus 1 over 8. So that was the 7th partial sum. So if I want to know the nth partial sum, I'm going to replace the last terms with the correct formulas, and the first just stick around as they are. So Sn will equal 1 over 1 minus 2 over 2 plus 1 over 2, the annoying pieces at the start that didn't cancel nicely. And at the end we've got plus 1 over n minus 2 over n plus 1 over n plus 1, because 8 is 1 bigger than the 7. So when it was a 7, we had a 7, so n. When we had a 7, we had a 7, so n. When we had a 7, we had an 8, so n plus 1. So we can simplify this a little bit and see that Sn is equal to, well, the 1 and the 1 cancel, so I'm left with a 1/2 plus 1 over n minus 2 over n is the same as minus 1 over n plus 1 over n plus 1. So we have a formula for our partial sums. We look back up and we see that, oh yeah, S is the limit of the partial sums. So S, the sum of this series, will equal this limit if it exists. If this limit is infinity, it doesn't exist, or we would say that the series diverges. So the limit as n goes to infinity of S sub n, which is the limit as n goes to infinity of 1/2 minus 1 over n plus 1 over n plus 1. And as n increases, we see that both of those fractions on the right decrease to 0. So the final sum is 1/2. So adding up these partial sums will eventually cancel down until there's only a 1/2 left. So that's how we do all of the telescoping ones. We break them apart with partial fractions, try to find a nice formula. We write out a few terms first to get our feet wet, but then you want to find the general term, the pattern. To find the general pattern, you look at what canceled, what stuck around at the beginning, and what stuck around at the end, and then you find a pattern so you can take the limit. Hope that helps.